Let's go ahead and look at some other physics terms. So we have speed, velocity, acceleration, and momentum. These are very basic physics terms when it comes to motion. We are going to be working math problems with these four things. So it is important that you understand what it is. I am going to give you the formulas today. We're not going to work out math problems today. We'll do that next week. So today you're just going to take notes on it. All right, so speed is just how fast you're traveling. And the formula for speed is distance over time. So that's distance over time. In the United States, we refer to speed a lot as miles per hour. So that would be miles per is the divide line. That's what that means. Miles per hour. So it is miles divided by the hours that it took. A lot of times you see that represented as mph, miles per hour. We're not going to use a lot of miles in science class because in science we usually use the metric. So the most common one for that is meters per second. So meters per second. This can also be minute, hours, but meters per second is the most common one that we'll be using. All right. So the next term is velocity, and velocity is just speed with a direction. So it's how fast you're traveling in that direction. So this could be 25 meters per second north. That would be a velocity. There's absolutely no difference in calculating velocity and calculating speed. Velocity is just distance over time as well. It's the same thing, it's just got a direction associated with it. The direction could even be you're driving 50 meters per second toward the building at the end of town. It doesn't necessarily have to be a specific direction, north, south, east, west. It can just be in the general area. Or she was going 60 miles an hour toward Walmart, okay? So you're going to see that velocity and speed are interchangeable a lot. They use them a lot just because you're always driving towards something usually. So to find velocity, velocity is distance over time. A lot of times you're not even going to see stuff referred to as speed. This one they kind of take out of the equation because it's the same thing as velocity. So just know that speed and velocity are the same. You find them the same way. They're not exactly the same. Speed doesn't have a direction, but velocity does, but you find them the same way. Okay, the next term that we have is acceleration. And this is just how you gain or lose speed. And you hear people talk about this all the time, like they accelerated or they accelerated around the curve or they decelerated. If you gain speed, it's a positive acceleration. If you lose, it's a negative acceleration. So it is okay when you work out an acceleration problem, it is perfectly fine to get a negative number. Negative acceleration just means that you're slowing down. So when we're talking about acceleration, the main thing that you're going to see probably on your test with acceleration, you are going to have to work out some problems, but you're also going to have to look at graphs. And I'm going to go over some of those with you in just a second. But anyway, acceleration, the units for acceleration are going to be meters per second per second. And sometimes it's just easier to abbreviate that meters per second squared, okay? But you may see it either way. If you see meters per second squared, it is automatically going to be an acceleration problem. If you see meters per second, that is acceleration. Okay, so the formula for acceleration is just going to be acceleration is change in velocity over change in time. So remember, I just told you that velocity is just the speed, so it's the change in speed. A lot of times you might see it written, acceleration is VF minus VI over change in time. So that's the final velocity minus the initial velocity over the change in time. The change in time will either be given to you, it'll say that it ran for 6 seconds, that would be the change in time, or it will give you a starting time and an ending time, and you have to figure that out yourself. So units for acceleration, meters per second squared or meters per second per second. And then the formula for it is, and anytime you see a delta, which is just a little triangle, that means change in. So a delta means change. That means that you are finding the difference. So basically, you're taking the bigger number and subtracting away the smaller number when you're finding the difference. Okay? All right, I'm gonna erase momentum for just a second. I'm gonna show you some acceleration graphs, just what they would kind of look like. So if you're looking at graphs, if something's going at constant speed, it's gonna be a straight line. So that wouldn't have an acceleration because you're not going up and down in speed. If you're going a constant speed and then it goes down, this part right here would be a negative acceleration. Because you're going down, you're slowing down, you're coming toward zero, toward a stopping point. So that would be a negative acceleration. If you have a graph and it's going straight up, you're accelerating that whole time. Okay, so in this, the slope, which you've probably learned in math classes already, you've probably been working with the slope equation. Slope is just, for these graphs, is just going to be the, sorry, I lost where I was, change in acceleration over the change in time. So that would be your slope. So if it's really, really steep, you're accelerating really, really fast. If it's kind of more broad, then you're accelerating not so fast. If we have a graph that looks like this and then it accelerates, it's going to cause the speed and then accelerate it up. So this would be a positive acceleration. This would be a positive acceleration right there where it starts to go up. This right here would be a constant speed when it's a flat line like that. So that means that you've got it on cruise control and you're going 50 miles per hour and then all of a sudden you gun it and go up at a faster rate. That would be where you're accelerating it. Or you could be driving down the 4 lane and you could have it on cruise control
all of a sudden the red light changes and you have to come to a complete stop. So you're going 50 miles an hour, you slam on your brakes, you decelerate really fast. This would be like within a certain time frame from here to here. You decelerate and come to a stop, which would be 0. So that's how you read acceleration graphs. They're really simple. And all they're really going to ask you is where it's accelerating, or if it was positive acceleration or negative acceleration. And remember that it is totally okay to get a negative number on those. Sometimes it kind of freaks people out when they work out acceleration. It comes out to be negative. If it becomes a negative, that just means that you're coming to a stop or you're slowing down. All right, so the last word I had was momentum. Okay, so momentum is just the amount of motion an object has. We're going to think of it like the power you have when moving. And momentum is very closely related to the mass of the object. So it depends on the mass of the object and the velocity. Remember, it could be speed of the object. All right, so what does this mean? This means that people carry an amount of power with them. Objects carry an amount of power with them when they're traveling in motion, and that's based off of how fast it's going, or or how much mass that the object has. So, if let's say we're trying to knock somebody down, like we're in football, okay, and we're trying to knock somebody down. If I was out on the field running the same speed as a professional football player, the professional football player, which is going to be a big, tall guy, lots of muscle, he's going to have a lot of mass. Okay, doesn't mean he's fat, he just has a lot of mass, bone, muscle, all that, that gives him a lot of mass. And say we're running at the same speed. Me, I'm 120 pounds, I'm 5'3". So if me and the professional football player were running at the same speed, who would you rather have hit you, me or the professional football player? Hopefully it would be me, because I wouldn't have as much momentum. I wouldn't have as much power behind my motion because I don't have as much mass. Even if I was running the same speed, I wouldn't have as much mass. So it would hurt you less if I hit you as opposed to a professional football player that's, 250 pounds of muscle and 6'5" or whatever. That person is going to have a lot more momentum. They're going to have a lot more power behind their motion because they have more mass. We're running at the same speed, so they would still have more momentum. If you have a car that's going towards something, let's say that the car is going to hit a tree. Okay, if you're going 5 miles an hour in the car, it's not going to do as much damage. If you're going 50 miles an hour in the car, it's going to do a lot of damage because the 50 mile an hour has more momentum. It's the same car, has the same mass, it's traveling at a different speed. So the more speed gives you more power behind your motion, and therefore it's going to do more damage because it's traveling faster. It's just like if you have a train traveling at 25 miles an hour or a car traveling at 25 miles an hour, the one that would do the most damage if it hit something would be the train. they're both traveling the same speed, they have a different mass. The train has a lot more mass. It's going to do a lot more damage, has a lot more power behind that motion because of its mass. So, momentum is based off of the mass and the velocity of the object. It's just how much power is behind that movement. The formula for momentum is P, and it's a P because they've already used an M, like with meters and mass. They can't use another M. So P, so this represents momentum. Is equal to mass times velocity. So mass times velocity. And remember, velocity is just your speed. And and you don't necessarily have to give a direction with it, but if we're saying we're traveling toward that tree, it is giving it a direction in a roundabout way. All right, so that's the formula for momentum. All right, so next week we are going to work out problems with these. So this week you just need to take notes. You are going to have a quiz on your notes. You are going to have to submit a picture of your notes and complete the quiz.